Good morning, friends. In the last lecture, we have learned about the concepts of programming. We have seen the difference between the procedure-oriented programming and the object-oriented programming, right? We have already covered that. So now in today's lecture, we are going to cover the OOPS concepts. We are going into the more details about what exactly is the object-oriented programming is all about. What are the objects, what are the classes, what are the OOPS features, like we have encapsulation, data abstraction, inheritance, polymorphism, operator overloading, overriding, and all those things. So it's a very important thing, and we are going to cover this in today's lecture. So always remember that object orientation was intended to make thinking about programming closer to thinking about the real world. So the intent was to make programming thinking closer to thinking about the real world. Okay, so object-oriented programming is all about thinking like a real world problem. So if we want to understand the object in a computer program, we first want to understand what is the object in the real world. Okay, so let's try to understand about the objects, the first concepts in the object-oriented programming. So what are the objects in a real world? Is this apple is an object? Yeah, it's an object, right? Is this cup an object? Absolutely, it's also an object. This mug, this cup, absolutely, they're all objects. These are all things. So we understand that objects are separate from one another. Okay, this is a separate object. This is an apple and this is separate. This is an object, this cup is an object, and this another cup is also another object. They have their own existence, their own identity that is independent of other objects, right? But they are not the same object. They are different objects. They have their own identity. We know that being an object has nothing to do with the complexity, right? This cup and this apple is an object, but yeah, sure, this iPhone is also an object, right? An aircraft carrier can also be an object, right? These are all objects. So we can say that objects have their own identity, right? So this is the first thing that we have understand, that objects have their own identity. Like cup has their own identity, the apple has its own identity. So we understand that concept. Okay, now coming to the next thing, we know that objects have characteristics, right? Now coming to the second, characteristics. Objects have characteristics of their own, right? So these properties describes the objects. A mug can be full or an empty, right? An apple can be green or red. A lamp can be turned off or turned on, right? These are the attributes of any object, right? So these are called an attributes. They describe the current state of an object, and the state of one object is independent of one another. We turn one lamp off, it does not turn all the lamps in the world off, right? So these are the attributes or characteristics of the object. So the second point that we have derived is, the objects, let me increase the font here. Objects have their characteristics, or you can say that attributes, right? So we have derived that objects have their own identity. We have derived that objects have their own attributes. Also, please note that the most objects have multiple attributes, right? A mug can be full or empty or somewhere in between, but at the same time, it could be black or white or some other color. It could be large or small, right? So we can say that objects have multiple attributes. So objects have their own identity. Objects have their multiple characteristics or the multiple attributes. Okay. Now in the real world, objects have behavior as well. So coming to the third point, behavior. In the real world, the objects have behavior as well. Let me increase the font again. Okay. A telephone can ring, right? A telephone can ring. A plane can fly, right? And this behavior is specific to the type of an object. An apple does not ring, right? A telephone does not fly. But those three things, right, the identity, the attributes, and the behavior are the same three things that describe an object in the object-oriented programming language. So we understand that anything that has an identity, attribute or behavior can be termed as an object. So while in the real world we tend to only use the word object for the things we can see and touch, right? But in computing we can take it further. Sure, in a computer program we often have objects that represent the real world items, like car is an object, house is an object, apple is an object, but also a date could be an object. A time could be an object, a bank account could be an object, and you don't touch and hold a bank account in real life, right? We can say that objects in the computing world are not always the real things that we can touch right? Date and time, these are also be an object, right? So why the bank account is an object? Bank account can also be an object. It has an identity, right? It's a bank account object. One bank account is separate from another bank account. It's his identity. It has attribute or data, right? It could have its balance, it could have an account number, it can have an account holder name, and it has a behavior also, right? You can deposit to a bank account, you can withdraw from a bank account, you can open it or close it. And just as they don't have to be a physical items, objects in a computer program are not just the things with a visual appearance on a computer screen. So to conclude the concept of object, anything that has an identity, attribute and behavior can be called as an object. And it is not necessary that objects have always the physical things. The non-physical things can also be an object, like the bank account can be an object and the person can be an object. So when you are new to object-oriented design, it can be a bit of a challenge to figure out if something in your application is a new potential object or not. It's easy when your application needs something like car, employee, document, but say you are building an event management application, okay? In that case, we are not sure that it can be a object or not, right? So how we can identify if anything can be an object or not? So the trick is, anything that is noun can be an object, okay? That will help you out in many cases. So if you know, noun is not just the physical things. It's not just physical things, but people, places, ideas or concepts. These all can be called as nouns, and so they can be treated as an object in our object-oriented design. So yes, event can be an object as well. So that concludes our object. We understand what is an object is. An object has its own identity, has its own state, and have its own behavior. Okay, so these are the objects for us. So now, where these objects created from, they don't magically appear in our program. So how do we make them? Well, to do that, there is another word we must explore that goes hand in hand with object, and that word is class, right? So we understood the concept of object. Now these objects are created out of the class, so we have to see what classes are. So we can go into that. So what are classes? We use classes to create an object. We use classes to create objects, right? So we see above what are objects, and now we are looking into the classes. So the objects are created from the classes. So class describes what an object will be, but it isn't the object itself, okay? The class is not an object, but it describes what an object will look like, okay? Class is like a blueprint. Class is like a blueprint, okay? So if you see here, I have the diagram here. A detailed description, when you build a house, you don't directly start it to build the house. You prepare the blueprint first. If you wanted to build a house, you make a blueprint first. It describes everything about how that house will be built, but it isn't the house. You then use that blueprint to build the house. For us, we write the class and then use the class to create the object. Okay, same way. So here we are preparing the blueprint first, and then we are preparing the house from that. Okay, right? But first we prepare the blueprint, right? So in the same way, in our computer program, we first create a class. Okay, this will be the first thing that we will create. I'll make an object here. Okay, so this class is the first thing, and then from the class we will create an object. Okay. Okay, so we created the class first, and then we create objects out of those classes, right? And another thing to note here, as just as we could use the same blueprint to build one house, right? Okay, we have the one blueprint. This is the one blueprint, and then out of that one blueprint we create all the houses in the society, right? So same way, we can define the class once and then create 1,000 objects based on that one class. But the class comes first. The class comes first. That's what we write. So here we can say that the class comes first. That what we write. And then we create objects from this class. Right? So you understand the concept of class, right? It's like a blueprint. It's like a blueprint. This is the term that you should remember while thinking about the concept of classes. You know the objects, right? Now the classes. The objects are created from the class. So we create the class first, and then the objects are created from the class. And just as like the many houses can be created from one blueprint, and then we can have a one class and the multiple objects, right? Like in the above diagram here, if you see, I can show here. This is the person object, right? Person should have the name, should have the gender, and it has the behavior like walk and run and talk, like that. So this is the person class, and from this person class we can create as many objects as we want. You know, one for Bob. Bob is a male and he can walk and run. And then another object is like Alice. She is a female and he can walk and run. Another will be like Saurabh. He can male and walk and run. So from one person class we created a many objects. We have a bank account class. From this bank account class we have n number of bank objects, one for Alice, one for Bob, and like that, right? So you get the idea, right? So from one class we can create a multiple objects. Now coming to how to create a class. So for class has a name. Okay, every class has a name. Class has a name that describes what is it. It's a bank account, it's a person, it's a date, it's an object. So class has a name, okay? And it describes two things, attribute and behavior. What attributes, what pieces of information will describe each object and what each object do? Now you might see somewhat interchangeable terms for these words. Instead of name, we might say type. You know, class is a name, or you can say the type. You know, in computer program we can say the type. We have the car as a type, and then we can have a Ferrari which is of type car, and then we can have a BMW which is of type car. So this name and type are interchangeable. Interchangeable terms, okay? We create objects of particular type, right? So you understand this point. Now coming to the attributes. For attribute also you can say we have properties, like we said, see above, right? And generally the data, or you can say it's a data. And for behavior you might also call it as a functions or a methods. When you define the behavior in your class, you will call it as a method or a function, okay? So this completes the class. Class has a name, and then it will have an attribute and will have a behavior. So if your application is dealing with the banking, right? So we can create a bank account class, and the class would be called bank account. So I'm giving you an example of bank account class. So the class will named as bank account, okay? and then it will have an attributes and behavior. Okay, it will have an attributes and behavior. So this is the diagram that we use to describe a class in a understandable way. So this class known as bank account, it will have an attributes. The class will have an account number, a balance, when the account opened, what is the account type, whether it's a checking account or it's a withdrawal account. Okay, and then we have the behavior. You can open an account, you can close an account, you can deposit to your account number, and you can withdraw it from it, right? So this is the behavior. These are the data, or these are the properties of that bank account, and the name of the class is the bank account, right? So this is a good example for the banking application that is the class. So we first write the class. So this class we first create, and from this class we create an object for many account numbers, right? So we create a class first. That's an idea. So now each class, each instance, each object, whether 1, 2 or 1000, has its own identity independent from one another. I told you that from this one class we create 1000 objects, right? So if I come here, I say that from one class we create n number of objects, but these objects are independent to each other. Okay, so in above, class says that each object has a balance. Okay, here in this above example, they are saying that each class has an account number or a balance, right? But the individual object say, well, my balance is $500. The other one will say my balance is $1000. Okay, so these are the different objects. One person might have $500 balance, and another one will have $1000 balance, and so on. But the class is one, and every object must have the balance. It might have a zero balance, but we define the property that class should have a balance. Now we are not defining how much balance. That will come into the objects, right? So you get the idea what classes and objects are. We are using the classes. We are describing what an object would look like, and then we are using this class to create an object, the actual objects that we discussed above, that the real world entity or the nouns, right? So those objects are created from this class, and the class has a name, an attribute, and behavior. So the objects are of that type class. So you get the idea of the class. Now please remember that in many languages like Java, C++, many object-oriented languages, they have given you already a pre-created list of the class, like strings and dates. They are already a defined class in the language. So you can use this class to create a date objects or a string objects to use in your code. You do not have to write a class for that, because the language already created the classes for that. So you can directly create an object from those predefined classes and use in your program. So one last thing that I want to touch in classes and objects is, like, from the class we create an object. So this creation of objects is called an instantiation. It's called as instantiation. So object is also known as instance of a class. Okay, so we have this bank account. This is the class. Okay, from this class we are creating an object, and we can create a multiple object. So like Joe account, Alice account, Sam account. So Joe account have this account number and a $500 balance, and it is opened on this, and it is a checking account, and we can open it, close it, deposit from this, and withdraw it. So like that, Alice account must have the different account number, it have the negative balance, it have the open date, like this. From all these objects, like these are all the objects or are all the types of this class bank account. So you get the idea of the class, right? So these classes and objects are very important. Now this is complete. Like, to be able to write our own classes, we have a very few more principles to keep in mind. In object oriented programming, they give few principles or few rules that we need to follow while writing these classes. Like these are abstraction, polymorphism, inheritance, like that. So these features we use to write class properly for the object oriented programming design. So that we can take a look at next session. But for now, I conclude this session. So we have covered objects and classes in this session. So if you have any doubt, please comment or please email me at gagsaurabh786@gmail.com, and please subscribe. Thanks for watching the video, and I'm very grateful to you. Stay in peace. God bless you.